Absolutely. Here's a very detailed, engaging, and visually dynamic topic. How self-driving cars work. The future of autonomous mobility. Chapter 1. Introduction. Welcome to the future. Hey there, curious minds. Welcome back to the channel, your gateway to exploring the technology that's reshaping our world. Today, we're diving into one of the most revolutionary advancements of the 21st century, self-driving cars. From science fiction to scientific reality, autonomous vehicles are not just coming, they're already here, changing how we move, live, and think. But how do these vehicles drive themselves? How do they see, think, and act without human input? What makes them safe or risky? Buckle up, because in this video, we'll explore every system, sensor, algorithm, and ethical challenge that fuels this revolution. Chapter 2. The levels of autonomy, from assistance to full autonomy. Let's start by understanding the levels of driving automation, defined by the SE, Society of Automotive Engineers. There are 6 levels, from 0 to 5. Level 0, no automation. Humans do all the driving. Level 1, driver assistance, think adaptive cruise control. Level 2, partial automation, the car can steer and accelerate but needs human supervision. Level 3, conditional automation, the car can handle most tasks but may ask for human help. Level 4, high automation, no human needed in certain conditions. Level 5, full automation, the car can drive anywhere, anytime, without a driver. Each level is a leap in technology and trust. Most modern cars are stuck between levels 2 and 3. Chapter 3. How cars see, the sensor suite. Self-driving cars perceive the world around them using a combination of sensors, each serving a specific role. Cameras provide high-resolution visual data, like human eyes, used for lane detection, sign reading, and object classification. Radar detects the speed and distance of objects, even in bad weather. LIDAR, light detection and ranging, sends laser pulses to create detailed 3D maps. Ultrasonic sensors, used for close-range detection, like during parking. GPS and IMU, inertial measurement unit for precise positioning and movement tracking. Together, these sensors provide overlapping fields of view, a technique called sensor fusion. Chapter 4. The brain of the car, RE and machine learning. So now the car can see. But how does it think? The answer lies in artificial intelligence, specifically machine learning, ML, and deep learning. Self-driving cars are trained using vast amounts of driving data. They learn how to identify pedestrians, traffic lights, road signs, and other cars. These AI models use convolutional neural networks, CNNs, for image recognition and reinforcement learning to adapt to real-world driving behavior. Essentially, the car is constantly asking, "What's around me? Where am I? What should I do next?" All of this happens in milliseconds, thousands of times per second. Chapter 5. Localization, knowing where you are. GPS is great, but it's not always reliable. What happens in tunnels or dense urban environments? That's where localization comes in. Self-driving cars compare real-time sensor data to high-definition 3D maps of the environment. These maps include the exact position of every lane, curb, and traffic light. Using SLAM, simultaneous localization and mapping, the car can determine its exact position within centimeters, even without GPS. Chapter 6. Path planning, choosing the safest route. Once the car knows where it is and what's around it, the next challenge is path planning. This involves 1. Route planning, like Google Maps, but real-time and far more complex. 2. Behavior planning, when to change lanes, yield, or accelerate. 3. Motion planning, calculating the exact trajectory to follow, avoiding all obstacles. And it does all of this while adapting to ever-changing traffic conditions. Chapter 7. Decision-making, ethics, risk, and safety. Let's talk about ethics. What happens when the car must choose between hitting a pedestrian or crashing into a wall? These are known as moral dilemmas. Engineers use decision trees and probabilistic models to reduce risk. But even with millions of lines of code, no system is perfect. The goal is always to minimize harm, using risk assessment algorithms. Chapter 8. Testing and simulation, before hitting the road. Before autonomous cars ever touch the road, they undergo millions of miles of simulation testing. Companies like Waymo and Tesla use advanced simulators that replicate city streets, weather conditions, and human behavior. These tests help AI learn how to respond to rare events like sudden road debris, reckless drivers, or an unexpected jaywalker. Chapter 9. Regulations and law, who's responsible? Who's liable in an accident involving a self-driving car? The manufacturer? The software developer? The human passenger? As laws evolve, governments are drafting new autonomous vehicle regulations, including requirements for safety testing, insurance, and transparency. In some places, like California and Germany, driverless testing is legal. In others, it's restricted. Chapter 10. The big players, Tesla, Waymo, Cruise, and more. The race for autonomy is on. Some of the biggest players include Tesla, focused on AI and camera-based systems with full self-driving. Waymo, by Google, uses LIDAR and operates driverless taxis. Cruise, GM active in San Francisco with fully autonomous EVs. Aurora, Zoo, Baidu, and Apple are also in the game. Each company has a different approach. Some rely on more sensors, others on smarter AI. Chapter 11. Challenges ahead, the roadblocks to autonomy. Despite rapid progress, there are still major challenges. Weather conditions like snow and fog confuse sensors. Construction zones lack consistent lane markings. Human unpredictability, jaywalkers, aggressive drivers, cyclists. Cybersecurity threats, what if someone hacks the car? Solving these problems is the key to reaching Level 5 autonomy. Chapter 12. The future, what's next for self-driving cars? Imagine a world where traffic jams are history, drunk driving is eliminated, and transportation is accessible to all. That's the dream of self-driving cars. In the future, we'll see autonomous fleets, AI traffic systems, and possibly even flying self-driving vehicles. It's not just about cars, it's about transforming entire cities. Self-driving cars are more than just a tech marvel, they're a symbol of what's possible when machine intelligence meets human ingenuity. Thanks for watching CHIZHIM Science Tech YouTube channel and riding along on this deep dive into the world of self-driving cars. If you learned something new or found this fascinating, don't forget to like, subscribe, and hit that notification bell so you never miss an episode from our channel. Got questions about autonomous vehicles? Or want us to cover the ethics, the economics, or the coding behind it all? Drop your thoughts in the comments.